This is the final part of section 13.1, and we're going to talk about how interest reflects how money gains value over time when it is borrowed or lent. But on the other hand, in terms of the equivalent number of goods or services that a certain amount of money can buy, money normally decreases value. This results in a periodic increase in the cost of living, which is called price inflation. So we're going to learn this formula called continuous compounding, and it's going to help us gauge what price an item will be in the future. So it's A equals P E to the RT, A being future value, P being the principal, E is an actual decimal value on your calculator, R is a rate, and T is time in years. So if you have this calculator, the TI-30X, E to the X is a second function of ln. So if you want to do E to the X, you'd hit second ln. And then you would put in what you wanted to raise it to. So let's say we wanted to raise it to the fourth power. Okay? If you have the TI-84, it is a second function also of ln. So you could hit second ln. And then you'd get E with the box, and then you could put a 4 there and hit enter. So E is nothing you are replacing in the formula. It's a function of the calculator. So let's look at how this works. So let's say we're looking at the price of gasoline, and in 2019 the price of gasoline is $2.88. With a 5% inflation rate, what will be the price of gas in 2024? So we plug into here. We do 2.88 E, and E is raised to the product of the rate and the time that's gone by. So the rate is 0.05 times the number of years from 2019 to 2024 is 5. So you're going to put that in your calculator. There's all kinds of various ways. 2.88 second ln, and then in parentheses I can do 0.05 times 5, close my parentheses, and I get $3.70. Let's say that we're going to go 10 years and the average inflation rate has held at 8%. So we'll start with that same $2.88 where we start. E will be raised to 0.05 times 10. And same idea with your calculator, you get $6.41 per gallon of gasoline. Now there's other ways to find the future value of an item, and it uses a proportion, and the proportion uses a consumer price index. So CPI stands for Consumer Price Index, and it creates a number which reflects prices of certain items purchased by large numbers of people: food, housing, cars. So the proportion would be the price in 1 year and its CPI, which you read out of a table, over the price in another year and its CPI. So let's look at an example. So let's say that we are interested in a man's suit, and the table tells us that in 2002 the CPI number is 179.9, and in 2009 The CPI number is 214.3. So we're starting in year 2002 with a suit that's priced at $225. And we want to build a proportion so that we can estimate the price in 2009. So remember, the proportion has the years over the CPI. So let's say 2002. Actually, it is the price in that year, not the year, my apologies. So this is 225 over X, because we don't know the price in 2009. The CPI that corresponds to 2002 is 179.9, so we're going to put in 179.9 over 214.3. Remember, to solve a proportion, you cross multiply and you get $268 would be the estimated cost of the suit in 2009. Now, the last idea with inflation is this rule of 70. So when working with inflation, we can use the rule of 70 to estimate the years it will take for a product to double in price. And the way we do that is we take 70 divided by the annual interest rate. Now, because of how the formula is derived, we do not change the inflation rate into a decimal. We use the whole value. So using the rule of 70, how many years will it take to double a price if the inflation rate is 6%? So you would take 70 divided by 6. With your calculator, you get 11.7 years. So not quite 12 years, your price of an item would double.